Hello and welcome to my 30 Days of Cybersecurity Skill. This program is aimed at anyone who would like to begin a career in cybersecurity or in information technology. I know that there are a lot of people who would like to start a career in IT or cybersecurity. But what you are likely missing is good information, quality education, and access to hands-on training. These are the things that I provide in this program. I will, in the next 30 days, give you the meat and potatoes of what it takes to be a good cybersecurity engineer. I can't promise you that it will be easy, it will be fast, it will be simple. Because these fields are fields that come with a lot of responsibilities. And like any field where you have a lot of responsibilities, it requires a lot of preparation. That's why it takes time for anyone to become a cybersecurity engineer or an information technology engineer, because the responsibilities that will be put on you are enormous. Folks, let's jump right in. Today is the first day of my 30 days of cybersecurity engineering skill. Let's jump right in. All right, this is my curriculum here. In the next 30 days, we're going to do the following. The first 30 days will be spent learning networking. In the networking that we're going to learn in the first 30 days, the first 7 days here, will be geared towards cybersecurity engineers. After that, we'll spend 7 days on cybersecurity engineering, next generation firewall for cybersecurity engineers. We'll spend 3 days on system and cloud engineering and security. We'll spend 5 days on SIM, system information and event management. 3 days on threat prevention, detection and response. That includes email security, endpoint detection and response, comprehensive data loss prevention. That includes preventing loss of data through email, cloud, and endpoints. Vulnerability management, we'll spend 2 days on that. Identity and access management, 2 days. GRC, governance, risk, and compliance, will be what we will conclude the program with. Folks, let's begin our journey. What you're looking at here is a network diagram. You will need to learn how to create network diagrams as you embark in this journey. And not only will you need to learn how to create them, you'll need to learn how to read them as well, because you'll see plenty of them. On day one, we are learning about IP configuration and how to troubleshoot IPv4 addressing and subnetting. The important parts of IPv4, types of IPv4 addresses, etc., as you see on the screen here. Some important definitions that you need to be aware of. Number one, TCP/IP. TCP stands for Transmission Control Protocol, and IP stands for Internet Protocol. These two are two of the many protocols in the IP suite. The IP suite is a suite of protocols that makes up the rules for network communication. In simple terms, any device that does not meet these criteria cannot communicate on a network or on networks. Now, TCP and IP are two different protocols, yet you will tend to hear them together as if they're one and the same. But remember, TCP stands for Transmission Control Protocol, and IP stands for Internet Protocol. Now, as I mentioned, TCP is one of the protocols in the IP suite that dictates the requirements for applications to communicate between networks. IP itself, it gives the requirements for devices to have addresses for them to communicate on networks. Networks, any system that allows 2 or more computing devices to connect with one another for some intended or unintended purposes. Common types of network, we have the LAN, local area network. It is a network that is controlled by one group of people. Think about your house. You have a network. You can allow a guest to connect on that network. You give them the Wi-Fi password, likely, or you can disconnect them from the network. You pay for that. You control that. This is your network, your own network. This is a LAN, a local area network. Now, the caveat with the local area network is that it allows communication between devices that are on that same network and nothing more. If you need more than that, if you need to communicate outside of the local area network, you need a gateway. We'll touch on what the gateway is. WAN, a wide area network. You see, when you need to communicate outside of the group of devices that you control and with other devices, then you need to go to the wide area network, likely the internet. The internet is the biggest wide area network. Now, you can have a LAN that is subdivided into multiple sub networks, and that's part of the things that we will cover today. The gateway. What do you need the gateway for? Although it's not in those definitions that were given today, the gateway is the address that you need to communicate from the network that you are with any other network. Let's say you have a local area network that has two sub networks, right? Think about your house. If you had a Wi-Fi for yourself and a Wi-Fi for your guests, these would be two separate networks, right? If you want to communicate from your Wi-Fi, from a device that's on your Wi-Fi with a device that's on the guest Wi-Fi, then you would need to know the gateway. Your computer would need to know the gateway for your network so that your gateway can take you from your LAN or subnetwork to the guest subnetwork. Now, if you want to communicate outside of those two subnetworks that you control and with something that is on the internet, such as Amazon.com, let's say you want to go to Amazon.com, that means your computer is going to initiate a session from your local area network to Amazon.com's network. Then you still need your gateway and a few other things that will help you go from your local area network into the Amazon.com network. Okay. And the internet is, as I mentioned, the largest WAN that exists in the world, and it will be used to help you communicate with Amazon.com. Okay. Let's do some hands-on training. Every time you see these hands, that means we're going to do something hands-on. So, oops, that's not what I intended to put here. Let me bring this up real quickly. Okay. Over here, if you give IP config, you will bring up your IP configuration. And what did I do here, folks? Understand, this is what I did. I simply search for this app that's called CMD, right? If you search for CMD, I typed it wrong, CMD, still popped up, but I wanted to type CMD. Command prompt. If you open that, you give IP config. You type IP config. You hit enter. It will bring up the IP configuration of your Windows PC. And what you're looking at here is the IP configuration of my Windows PC. This is my IPv4 address. There are three things that I want you to know. Number one, this is my IP address. This is the address of my computer on that network. This is my subnet mask. This is the subnet mask of my IP address on that computer. And this is the gateway. This is the gateway of my subnet. You see, the gateway is the gateway of the subnet that my computer is on, or the gateway of the network that my computer is on. These three things are crucial for you to understand anything about networking. What is this? IPv4 address, 192.168.252.11. Well, this right here that you're looking at here is the address that my computer has on this network. Now, the subnet mask itself, it says how many other computers can be on that same network as my computer. I will dive into that later. The default gateway, it says if ever my computer wants to communicate with any other computer that's not in the range of IPs that can be on my subnet, this is where it needs to send the traffic. So you must understand these three, and we're going to dive very deeply into them. And for us to do that, we need to understand the concept of subnetting. Now, I already explained what that is. IPv4 address, the IPv4 IP version 4, v4 stands for version 4. It's the address of your computer. Subnet mask tells you what network the IP is part of and how many devices can be on this network in total. Default gateway, this allows communication between your network and other networks. Okay. Subnetting. Let's do some subnetting here now. You need to realize that networks can be broken into pieces. You can have a network that is very big, and you can have a network that is broken into two smaller networks. Understand that means if you originally had a network that had 100 possible devices that can connect to it, you can decide that you're going to break that in however many numbers that you want, so long as you have at least 2 IPs per network. So if you decide, okay, I no longer want to have 100 devices on my network, you can say, okay, I'm going to have 2 networks of 50 devices each. That's just hypothetical. That's just an example, right? But there are exact numbers that they can be. And we'll dive into that. We'll get to learn that. Now, if you decide I don't want to have 2 networks at 50 addresses each, you can say, okay, I'm going to have 4 networks at 25 addresses each, or 10 networks at 10 addresses each. You see, you had 100 IP addresses or 100 host IP addresses. Host here stands for computer devices that are on the network, like the computer that I am using now, or a tablet, a cell phone, or anything else that needs an IP for them to communicate. Now, and you decide, I'm not going to use 100 anymore. I'm not going to allow 100 devices to connect on my network. I'm going to break it into 2. Maybe you want to have one network for your family, one other network for your guests. That way you separate the 2, right? You use subnetting to do that. The subnetting concept allows you to break networks into multiple. The subnetting concept itself allows you to break big networks into smaller networks. Okay, or smaller subnetworks. That's how I want to say it. There are 3 types, 3 classes of IPv4 addresses that you need to be aware of. Class A, Class B, and Class C. Now, you will understand by the end of this session what the /8, /16, or /24 means. But first, let's understand the numbers that you see in the IP address. Look at this here, right? You see 4 numbers here, right? 192, there is a dot, and a second number, 168, a dot again, 8, a dot, and 254. What are these 4 numbers? Each one of these numbers is called an octet. Why is it an octet? That is because the IP addresses are written in binary number system. You see, we, the humans, we communicate in decimal number system. When we're counting money or counting whatever, we use the decimal number system. But the computers themselves, they don't use that. They use the binary number system. And in the binary number system, things are written. Every digit is written using 8. Every number is written using 8 digits. So if you want to write this number here, 192, from the human number system, which is decimal number system, to the computer number system, which is the binary number system, then you will need to have 8 digits to represent the 192. That's why it is called an octet. The octet stands for 8 digits. Now, you can go further. Those digits can also be called bits, right? So you can say, okay, you need 8 bits for each octet. Each octet has 8 bits. Since you have 4 octets, 4 times 8 equals 32. That's 32 bits. An IPv4 address has 32 bits. Okay, now that this is clear, we understand why these are called octets. So the first number is called an octet because in binary it has 8 digits or 8 bits. The second is an octet, the second octet, because in binary it has 8 bits. Same thing for the third and same thing for the fourth. Now for the fourth, I took the liberty of not just writing fourth octet, but putting the 8 possible digits that this can have. And what you see here, folks, is once you understand that each number in the binary number system has 8 digits or 8 bits, then you realize that when you have the first 3, well, before I say that, I need to say as well that In the binary number system, you have two possible digits, 0 and 1. In the decimal number system, you have 10 possible digits, right? 0 all the way through 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 10 possible digits that you can use to write numbers in the decimal number system, or the human number system, should I say. In the binary number system, or the computer number system, you only have two, 0, 1. You either write 0 or you write 1, right? Now, when all the first 24 octets are ones, that means you have a /24. When all the first 8 octets are ones, you have a /8. /16 is when the first 16 octets in the binary number system of your subnet mask are 1. We're talking here about the subnet mask. Understand that the IPv4 address is made of three major components for you as the person who's using that. The first is the IP address of your host or your computer or whatever device you're using. The second is a very important one. It's the subnet mask. And the third is the gateway. The subnet mask tells you how big the network you're part of is. The IPv4 address tells you what your address is, or should I say, what the address of your computer is. A computer can be this watch, it can be a telephone, it can be the computer that I'm using, etc. Right? All of them, as they connect to networks, they need to have an address that is unique to them. Two of them cannot have the same address, otherwise they cannot communicate. Now, the gateway tells you how you go from the network that you are to other networks. This is like the intersection, right? If you want to send anything from your computer to another computer, you've got to go, if you're not on the same network, you've got to go through the gateway. If you're on the same network, you don't need the gateway. Okay. With that clear, we understand as well the class A, class B, class C. We understand that each number in the IPv4 is called an octet. We understand if the first octet has its subnet mask all ones, right? You have a /8. If the subnet mask of the has the first 16 bits ones, you have a /16. And if it has the first 24 bits ones, you have a /24. And what we're talking about here is that each octet here, when written in binary, can be either 0 or 1, right? And since the subnet mask is also going to be written in binary, if the subnet mask has the first 8 digits all ones in binary, then /8, the first 16 all ones /16, the first 24 all ones /24. Now, look at the last octet here that I wrote for you. I give you a lot of information about it, right? When you're subnetting a network, right? First thing you need to know is that if you have one, if in the if you have a /24, a class C address, right? And you have one subnet, you're going to have 256 IP addresses. And your subnet mask here is going to be /24, right? The /24 here would mean that you have the first 24 bits on, right? And if that's the case, then you're going to have, you could write that in decimal, 255, 255, 255, 0, 255.255.255.0. This 255 here stands for the first 8 digits here, right? If you want to write 255 in decimal, you write 8 ones, right? That's the same thing. You write 8 ones here, that represents 255 in decimal, right? So in binary, 8 ones equals to 255 in decimal. In binary, 8 zeros equals to 0. So that's why you can say, you can write it either that way, 255.255.255.0, or if you wanted to be fancy, or if you wanted to simply write it in binary, you could write it that way as well. It's equivalent to that. But you can simply say /24. Why? That is because the first 24 bits are ones, If you count here, you'll see 24 ones, and that's what the /24 represents. And how did you get those 24 ones? By writing your subnet mask from decimal to binary. You see it? That's where it came from. Okay. Now, if you have that, you're going to have 256 IP addresses in the subnet. There's a rule of IP that says the first IP address in a subnet cannot be used, and the last IP address of a subnet cannot be used. The first IP of a subnet is called the network address. The last IP of a subnet is called the broadcast address. We'll get to know what these are. You cannot use these to assign to any device. So you've got to start with the second IP, and you've got to stop right before the last IP as you are assigning IP addresses to the different hosts of your network. The hosts here, again, stand for the computers that are connected to the network. Okay. Let's continue with subnetting. The binary conversion. Let's convert numbers now from decimal to binary. Now, here's a cheat sheet that I created for you to understand how to convert any number from decimal to binary. Understand that if any number will have 8 digits in the binary number system, and those digits are going to be either zeros or ones. So you might as well just create 8 little boxes here to represent your 8 your 8 binary digits or your 8 bits. So I created this first line in green here to represent that for you, right? 1, 2, 3, 4, 5, 6, 7, 8. So 8 bits, right? I call this the 8-bit binary number line. Okay. So second thing that you need to do is this. I'm going to go to the third line. I call this the binary base 2 exponent line. Well, what this does is that because the binary number system only has 2 possible digits, then we're going to use number 2 as the base of our exponent line. And we're going to raise that number 2 to some exponential number. The first one will be 0. So 2 to represent the 2 digits of the binary number system, and we raise that to 0, right? That would be our first bit in the 8 bits of the binary number system that we have. Okay, so once you calculate that, you put it in the calculator, 2 to the power of 0 will give you 1. You put it over here in the decimal number line. That those things, to understand that they don't exist. There's no rule, there's no book that says that. I just created that way so that you can remember how to do that conversion. So 2 to the power of 0 equals 1. You do the next exponential number, which is 2 to the power of 1. That would be equal to 2. And you continue to do that. You do that 8 times because you have 8 digits to represent here. The last one will be 2 to the power of 7. And you calculate that, and you put the number, the result here. Why did we do that? And here's why we did that. To simplify the subnetting process, right? And what I mean here by simplifying the subnetting process is this. Think about if you have number 95 to convert from decimal to binary. What are you going to do, folks? Here's what you're going to do. This table here, or this cheat sheet here, is all you need. You're going to take enough numbers here to represent 95. You're going to add them all up, right? And wherever you add a number, you're going to turn that bit into a 1. So what did I do here? If I want 95, I know I cannot use 128 in my addition because 128 is already greater than 95. So I need to use enough digits here, right, to add them all up to give me 95. So let's start with, you say we're not going to use 128, right? So we make this bit 0. Second, we say, okay, we might need to use 64 because it's less than 95, and we can add some other numbers to it to make it 95. So let's put that as 1 for now. If we change our mind, if we realize that we can find other numbers to add up to give us 95 without using 64, then we'll turn 64 0. So you see here, the second bit, I turn it to 1. And what else do I need? I say, okay, if I put 32 here, it'll probably be too much. So I'm not going to put 32, 0 for you. 64, if I put 64 to that, let's bring up a calculator. Okay, oops, this calculator takes the whole screen. Let's make it smaller, right? So for those of us who are not mathematics genius, I have good news. We don't have to be able to do that. This is very, very simple. You just need to understand it. So I said, okay, let me add 64 plus 16, right? This gives me 80. Okay, I'm still within the 95. So I can add more numbers. So I turn this one into 1 for now. I said, what else do I need? Let's add 8. That would give us 88. Okay, we're good. We put this here. We can change our mind if we realize that we took the wrong numbers. We turn this into 1. So let's add 4 plus 1. That's 89. We're getting close to 95. Okay, so all of those that we chose the number for, we turn them into 1, right? So where are we? Oops. I did it wrong. Let me start over. I don't want to confuse you. So I'm going to restart this thing. So 64 plus 16 plus 8 equals to 88, right? We add 4 to it. That gives us 92. You see, everywhere we add a number, we turned it into 1. We add 2 to it, plus 2. That gives us 94. You see, folks, everywhere we chose one of those digits to add in our addition to count towards 95, we turn them into a 1. And we see there's only one that we can add here to make it 95, which is where the number 1 is, 2 to the power of 0. We add that one and we turn it into a 1. And this is how we write the number 95 in decimal. Look at that. 0, 1, 0, 1, 1, 1, 1, 1, 1. Right? This is 95. And how did we come up with this 95? We turned the bit. Wherever we used a number here, we turned the bit into 1. Wherever we didn't use a number, we keep the bit 0. And how did we come up with these numbers? We came up with these numbers by starting with 8 number 2s. We have number 2 8 times. And we raised this to some exponent. The first was 0, and the next was 1. The after that 2 all the way to 7. And we did the math, right? And we put those numbers here, right? Under those little boxes. If you do that, you can convert any number from decimal to binary. Let's say someone were to say to you, hey, write number 128 in binary. That would be an easy one. All you do here is to turn this bit on. Turning on means you change the bit from 0 to 1. And then you write all of the others 0. 1, 2, 3, 4, 5, 6, 7. Because I know my binary number will have 8 digits. So 1, which represents 128 here, and all of the others is 0. That's 128. Let's say someone were to say, write 64. Well, I wouldn't use 128 anymore. I would put this as 0. And I would go on the 64. I would turn it to 1. That's 64. Let's say someone were to say, write 255. Right? I would add all of these. You can take my word for it. If you add all of these, it gives you 255. And that would be 1, 2, 3, 4, 5, 6, 7, 8. Right? And that's how the subnet mask was written when we had the subnet mask earlier. Right? 255, 255, 255, 255. Right? That meant that 1 8 times. Right? And when you have that, if the first 8 bits of the subnet mask is written that way, you have a class A address. 8 bits on. The first 8 bits of the subnet mask are on. Right? Okay. So, without being long-winded here, as my friend would say, I am going to continue with this. I think now you understand very well how to convert a number from decimal to binary. You understand very well what the IP address of a computer is on the network. What the size of the network is. You simply use the subnet mask to know what the size of the network is. And you know how to convert from binary to decimal. You know what the gateway is, etc. Then, one more thing that you need to know is, how do you know how big the network is? Well, you know, in the class C address /24, right, where you had the first 24 bits on, if you do not subnet that any further, you have one subnet, then you're going to have 256 IP addresses. Right? Now, if you subnet it, that means one time. That means instead of one network, you have 2 networks. You're going to break your 256 into 2. That means 2 times 128. Right? 2 times 128 IP addresses. So, subnet mask here will be 128. Now, if you or slash 25. You see, subnet mask here should have said 255. I'm sorry, 0. 0 is good here. That 0 here represents this last 0. You see how the last octet is 0? If your last octet is 0 in the subnet mask, if the last octet is 0, that means the first 3 octets are 255s. The last octet of the subnet mask is 0. Then you know you have 256 IP addresses in that class C network. And it's only one subnet that you have. Or you can write the subnet mask as /24. This CIDR stands for classless interdomain routing. So you can write it, the subnet mask, either like that, 255.255.0, 255.255.255.0, or /24. Or you also know that means you have 256 IP addresses in that class C subnet or /24 subnet. You know you have only one network, one subnet. So if you want to have 2, you're going to write the subnet mask as /128. /25. Simply what that means is that instead of your first 24 bits being on, you move your bit one step towards the right, right? You add one more bit, you turn one more bit on, and that's the whole idea of subnetting. You see, when you had 24 bits on, you had /24. If you want to subnet, the first thing you do, you add one more bit on the subnet mask, right? If you do that one time, just one time, that means you have 2 subnets. You understand? Now, if you do that 2 times, if you do that one time, that means you have 2 subnets. If you do that 2 times, that means you have 4 subnets right there. And you're not going to have /24 anymore. Here you have /26. If you do that 3 times, right, you move the subnet, you turn one more subnet mask bit on, you have /27. And /27 would bring you here, right? And, oops, I said if you do that 3 times, that means you do that the first time here, second time here, third time here. Okay, the /27 here. How many hosts would you have? 32. What would be your subnet mask? The last octet of the subnet mask would be 224. You can write 224 here. 255, 255, 255, 224. You got the idea here. This is the size of your network. You see the same thing here could say 192.168.8.255 /27 or 255.255.255.224. That's your subnet mask. You understand that if this is your subnet mask, that means you have 32 possible hosts on your network. The size of the subnet is 32 because you have the last octet as /224, right? Or the last octet as .224, or in CIDR /27. Folks, that's where I'll stop for now. I don't want this to be any more confusing. I will continue to talk about subnetting, as this is a very important concept of networking as well as of cybersecurity. If you want to be a cybersecurity engineer, you need to understand this like the back of your hand. If you want to be a network engineer, you need to understand this like the back of your hand. I will cover this in great details as we go along in this class. Let's stop right here. I think you have learned enough for today. This is the first day, and I welcome you to my 30 days of cybersecurity skills hands-on. Thank you.